Asynchronous programming in C# allows developers to create responsive applications by performing tasks in the background while keeping the user interface active. However, there are common pitfalls that can lead to issues like unresponsive applications, deadlocks, or unexpected behavior. In this lesson, we will explore some of these common mistakes and learn how to avoid them while implementing asynchronous code. Don't worry if this feels new at first. Now we're on understanding asynchronous programming. Before diving into the pitfalls, let's clarify what asynchronous programming means. In C#, asynchronous programming is primarily achieved through the use of the async and await keywords. This allows methods to run in a non-blocking manner, enabling the application to remain responsive. A common misconception is that asynchronous programming is inherently faster, but it's more about improving responsiveness rather than execution speed. Now, common pitfall 1, forgetting to await. One of the most common mistakes is forgetting to use the await keyword when calling an asynchronous method. When an asynchronous method is called without await, it runs in the background and the calling method continues executing without waiting for it to complete. This can lead to unexpected behavior and results. For example, consider the following code. See the example on this slide. Pause if you want to study the details. In this example, the fetchDataAsync method starts executing, but the result is accessed synchronously, which can lead to a deadlock. The correct approach is, this section covers common pitfall 2, blocking calls in async methods. Another mistake developers often make is using blocking calls such as task, wait, or task result inside asynchronous methods. These calls block the executing thread until the task completes, negating the benefits of asynchronous programming. For example, the samples on screen walk through this step. Take a moment to read through them. Instead, you should ensure that all operations are asynchronous. I'll let you read the examples on screen rather than reading every line aloud. Let's move on to common pitfall 3, not handling exceptions properly. When dealing with asynchronous code, exceptions can be more challenging to handle than in synchronous code. If an exception occurs in an awaited task, it won't be thrown until the task is awaited. If you don't await the task, you might miss the exception entirely, leading to silent failures. For example, see the example on this slide. Pause if you want to study the details. To ensure exceptions are handled, always await tasks. The samples on screen walk through this step. Take a moment to read through them. Now, common pitfall 4, ignoring context switching. When using await, the continuation of the code after the await statement may not run in the same context, e.g., UI context in a Windows Forms or WPF application. This can lead to issues, especially if you try to manipulate UI elements after an await without ensuring you're on the correct context. For example, I'll let you read the examples on screen rather than reading every line aloud. To avoid this, you can use configure await false in library code to prevent capturing the synchronization context, but be cautious when updating UI elements. See the example on this slide. Pause if you want to study the details. In this lesson, we explored several common pitfalls when implementing asynchronous programming in C#. Remember to always use await when calling asynchronous methods, avoid blocking calls, handle exceptions properly, and be mindful of context switching. By adhering to these guidelines, you can create more robust and responsive applications. Go ahead and work through this exercise. First, implement an asynchronous method that fetches data from an API and displays it on a UI element, ensuring that you handle exceptions appropriately. Also, refactor an existing synchronous method to use asynchronous programming principles, avoiding blocking calls. Finally, experiment with configure await false in a library project and observe its effects on synchronization context.